Welcome everybody to this session about rapid threat containment. My name is Hakan Nohre. I'm a technical solutions architect specializing in cybersecurity, and I work for Cisco Systems. I also have some other stuff here at GrayHat. I have two different offensive security labs. One is called Hacking in the Kill Chain, and the other one is Hacking Web Applications. And they are run from Thursday to Saturday this week. And with me today, I also have my friend and colleague, Christopher van der Made. Do you want to introduce yourself, Christopher?
Thank you, Hakan. My name is Christopher van der Made. I'm a developer advocate at Cisco. That means that I focus basically on anything that has to do with our APIs, automations, integrations. And I'm part of Cisco DevNet, or the developer network. And I specifically focus on all security technologies that we have. So obviously this project is something which is very well aligned with my job. So hopefully you'll enjoy and you'll understand what I'll mean at the end of this presentation. Thanks, Hakan.
So thank you, Christopher. Yeah, Christopher and me, we've been doing some projects together. We like to see ourselves like brothers in combating crime. We don't mind the comparison with Batman and Robin, but maybe we also don't mind other comparisons between other famous teams. So, the agenda today, we're going to start with a very brief introduction, and then Christopher is going to define the problem that we are trying to solve. And then I'm going to talk a little bit about some nuts that we had to crack in order to solve this problem. And then Christopher is going to do an overview of the solution, and I'm going to finish up with some demo before Christopher does the closing. A little bit of the introduction. The inspiration for this project came from a hackathon where lots of different people from Cisco with interest in development and programming combined with some technical solutions from Cisco and other vendors. We met in sunny Florida, and we spent like 48 hours without sleep with lots of junk food, and to try to come up with ideas and to implement these ideas in our favorite programming languages. So that is really the background, and since then the project has traveled a little bit. It's been a project also used by Cisco Advanced Services for a major customer. So, over to you, Christopher, then, and the problem statement.
So thanks, Hakan, for that introduction. And it indeed was a lot of fun, the hackathon. Luckily, we are now, I think, almost 2 years later, and we're still working on the same project. So yeah, that shows how much we like it. And yeah, we think that this is a great idea still. And I think this is also where the market will be going. Now, before we go any further, let's state the problem first. So let's have a look at what is the actual problem right now. So to start off with that, I have a question to you. What is the enemy of automation? Because obviously we're talking about, it's still a bit vague for you probably, but we're talking about threat containment, automation in that sense. But why isn't automation more and more happening with regards to containing threats? So the question or the answer is false positives. So whenever you're talking about quarantining hosts, quarantining devices, users, or containing them, whatever you want to call it, people get scared if you want to do that automated. What if it was a false positive and we have now quarantined the CEO's laptop with no good reason? So that is why people are scared of automation, and that is the biggest reason is false positives. If this would work flawlessly, you would be a fool not to turn on this automation, in my opinion. But obviously we are not there yet. There are still a lot of false positives that are being made. So what is threat containment or quarantine? And again, or isolation, there are a lot of terms that are being used. So let's set the stage a bit for our interpretation of those words. So we call threat containment or rapid threat containment. We'll talk about it in a little bit, but first we'll talk about threat containment. We call this the blocking and minimizing of network access for a host based on security event or multiple events. So you can do this in a couple of ways. This is not an exhaustive list, so there are probably more ways to do it. You can do it with network access control solutions like Cisco ISE or the Identity Services Engine, or one of our competitors obviously is also possible. And there's multiple network access control solutions out there. So they can change basically the access that a host can have. So there's an active session with that host and it will change the authorization basically. So that is one possibility and we'll definitely explore that one in our project. Other one could be maybe a very simple one, reconfiguring access control rules on a firewall or on a router, like Firepower, next-gen firewall, ISR router, or any other device out there that can do access control rules. Now the third solution is probably a little bit more what we're going to see in the future is endpoint security solution. So an agent either being native or installed on an endpoint. So it can be a laptop or whatever mobile device, any kind of endpoint basically. And that agent itself has capabilities to basically block network access. Now, just 2 notes, blocking access to a file on an endpoint sometimes is called quarantining a file. Obviously, email solutions can quarantine an email as well. So we're not talking about that today. We're talking about restricting network access to basically do 2 things: stop the spreading of malware and stop the exfiltration of data. So you want to control that. So that is what we will call threat containment. And so during this presentation, please keep that in mind. And by the way, very important before I continue, basically the customer can decide what this means, right? So whatever response action you want to attach to security events is totally up to the customer or the organization implementing this. So it can literally be anything. It could be using multiple security events to brew a cup of coffee for the security operation center analyst. I'm just saying. So let's look at a couple of examples. So here we have an example of a user or a client on a network, and basically it has been compromised. So what will this malware do? Malware usually tries to do a couple of things, but one of the things it will try to do is go to the rest of the internal network and the internet, either to compromise more hosts, to maybe do crypto mining, maybe do data exfiltration, but usually it involves the network. Of course, unless it's ransomware, then it usually does that on the host, but still ransomware needs to phone home and call home to the command and control server. So it usually involves network traffic, which the malware is doing. So basically you want to stop that, as you can see from the stop sign immediately, and basically not allow any network traffic. Now, as is mentioned here, what you can do is allow access to maybe a forensic system, a forensic analysis system. So you can do that either by not allowing anything, but only allowing access to a specific sort of honeypot forensic analysis server. Or you can also do some traffic engineering, like traffic steering, like DNS sinkholing, for example. So there are a couple of ways on how to do this, but important is that we at least stop all unnecessary network traffic. Now, a second example here is, what if a compromised device is a critical server? And a critical server must be reinstalled as soon as possible. So you can't really risk reinfection without knowing the root cause. So what you can do here is just stop access to the rest of the internal network and the internet. Maybe do some traffic engineering again against a forensic analysis system and allowing traffic there directly. But what you can also do is wipe the device automatically and basically install a new backup on it so that the system can be up as soon as possible. So that's obviously important for critical servers. So this is another example of threat containment. This is obviously how the malware would try to reach the rest of the network and the internet. Now, what is rapid threat containment? Because obviously our project is called Rapid Threat Containment, or RTC as we call it in abbreviated. So this is basically the exact two examples that we just talked about, but to do it as soon as possible, so to do it now. So usually when malware is installed on some kind of device, you don't have hours, days, or weeks. You want to be within minutes or maybe even seconds to decide to stop that malware from spreading or data from being compromised or stolen. So in order to be able to do this fast or rapid, you need to be prepared. So preparation is really key here. You need to know what kind of scenarios there are for your organization, and you need to be able to decide what the steps are to be taken when some scenario like that happens. So if a critical server is compromised, what do you do? If a client is compromised, what do you do? If an IT admin device is compromised, what do you do? So you really need to be prepared, and knowledge of your network and of all of your devices either inside or outside your network or maybe in the public cloud is also key. Now, automation may help here to do this rapidly because humans can only do stuff, basically as fast as they can type and respond to something. And usually they have a lot more to think about. So automation is really important to do stuff like this and to perform these actions automatically. Now, you don't necessarily have to do the containment automatically, but at least you can gather all the actionable intelligence automatically and provide it bite-sized to a security operation center analyst or a network admin. Like, hey, this is the situation. You want to press the big red button, yes or no? So it can also be semi-automatic. And again, here it's important to note that the customer must decide what this means. So rapid threat containment can be anything. As mentioned, brewing a cup of coffee for the SOC analyst could also be a response action. I would recommend the first or the second option, so at least gather actionable intelligence and hopefully also do actions automatically. So that was the problem statement. Now I'll hand back the word to Hakan, who will talk about the nuts we had to crack.
So next we're going to look at some nuts we had to crack in order to come up with a solution for rapid threat containment. So the first problem is to define what security events are really relevant for rapid threat containment. And there are a vast amount of security events which are not relevant. And these are all things that have been blocked by our security systems, where our firewalls or our endpoint protection or other security systems have done their job, such as our IPS blocks an incoming attack from the internet to one of our public web servers, such as the email security systems blocking a phishing email, or our antivirus or endpoint protection is blocking a malware files. All these events we don't really care about because they have already been blocked, so that they are not really relevant from the perspective of rapid threat containment. We are only here looking for signs of compromises, where our security systems may not have worked. So, what security events then could be relevant for rapid threat containment? Well, it could be, for example, an IPS event from an inside host. Yeah, completely different compared to an IPS event from a host on the internet. We could also consider malware files that have been retrospectively found. With that, we mean that the file has been allowed to execute before we knew this was a malware file. And maybe we found out later because of techniques such as sandboxing or because of the threat intel community. Also, of course, outgoing command and control from its inside host could be very serious evidence that a host has been compromised. But we also have these types of events that I've marked in orange here, and these are less conclusive events. It could be, for example, we have a host with frequent requests to a newly seen domain on the internet. That could be an indication that it may be compromised because many malware campaigns use newly registered and newly seen domains. We also have like network anomalies or unusual login times. None of these orange events here are conclusive evidence that the host has been compromised, but we should still not discard this information. Maybe we can keep track of it and use it in some sort of penalty systems that Christopher will talk more about later. So, another thing then here is how do we track the targets on the inside that are under attack? Many security systems, such as firewalls, etc., primarily track the IP address. And that is not a very good tracking attribute because IP addresses are typically not persistent. You use DHCP, etc. So the same IP address could be owned by different users on different occasions. Traditional security systems may also track MAC addresses. Sometimes they can, sometimes they can't, depending on whether they are layer 2 adjacent or not. But the MAC address also has a problem. It's actually not persistent anymore. Many operating systems have introduced MAC address randomization for privacy reasons and integrity reasons. And you can also think about one PC, for example, may have different MAC addresses on different NIC cards. We can also try to keep track of systems by using their host names. And this is specifically true if we have some sort of endpoint security system running there. So the host name could be a very good and persistent indicator of what machine it is that has been attacked. But of course, the drawback is that it requires some type of endpoint software. And also for cloud systems, maybe in the public cloud, we may have to keep track instead of the instance ID, for example, the instance ID of an EC2 instance in Amazon. We have it here. And this is, of course, then only relevant for a public cloud. And another thing, which may be the best thing to keep track of, is actually the username, if this is a client system. Then we have to discuss later then how to grab this information about the username. And we also have to note here that different systems may need different formats for the username. Some may use the SAM account name, the logon name to the Active Directory. Some may use something like an email ID or a user principal name. And some may use the distinguished name, maybe from a certificate that has authenticated to the network or to an application. So I think both Christopher and me, we were convinced quite early in this project that what we need to do when we discover an event that may be relevant is to collect and grab as much information as possible from different sources and try to correlate this. So a little discussion then about how to grab an user information if we know the IP address. And one way of doing this is to pass the Active Directory logs. And this is a very typical method that you will find in legacy next generation firewalls. That you have something that reads the Active Directory logs where you will find the username and the IP address of the device doing the Active Directory logon. The drawback here is that this will only work if there is an Active Directory logon, so it will not work for devices which never logs on to Active Directory, such as bring your own devices, IoT systems, etc. And another thing I don't like with this method is that it may be tricky to detect when a user just closes his laptops and leaves the network, that we will not really see that he's not really using that IP address. A better way of keeping track of users and IP addresses which are on our internal network is if you're using Radius logon with .1x standard, you can grab that information directly from the network access server. So in this example, we are using Cisco's network access server or Radius server, which is called Cisco ICE, but this will work also for other vendors or for open source Radius servers. This requires then log on to the network via the standard 802.1x, but this will then work with any device that logs onto the network, including IoT systems, bring your own device, etc. And here we also have a very good method of keeping track of when devices leave, like just our laptop being closed down, because we will then get the link down event in the network device, and that can be signaled to the Radius server through a Radius accounting message. And if you're lucky, the Radius server here can also give potentially other information about the device apart from the username, such as certificate information, MAC information, information about the type of profile device, and much more. And then we have a third method of grabbing information about the user from an IP address here, and that is ask the endpoint security system. The drawback here is, of course, that it requires that we have some sort of endpoint security system, but it has many advantages. For example, it works also when the client system is off-prem, maybe at the home office, and it can give much more context about the system, such as the operating system versions, vulnerabilities, and many other things that we can only get if we have something running on the endpoint system. So an example here is that we would like to, in our project, to combine multiple sources. It could be directly from Active Directory, it could be from the Radius server, it could be from endpoint security systems, or it could be from public cloud, such as AWS. And we are trying here to really build a table where we fill in as much information as possible for each relevant security event that we have seen. And with that, over to Christopher for an overview of the solution.
And indeed, these were some tough nuts that we had to crack. And I think at the beginning of the hackathon, if you asked me, like back when we started this project, this was like a lot of tough decisions that we had to make. So that was very interesting. Yeah, how do you normalize the identity for hosts and users in your network? And in your organization, of course. So next up, we'll talk about the solution. So what is actually the solution that we together made over the past months and years? So it all started with correlating security events from any source to reduce false positives. That was basically our mission. Because if you want to do a quarantine action or a threat containment action rapidly, aka do it automatically, one security event will probably not be enough. So you want to make sure if this system has a security event, what do other systems that are also monitoring that host say? And is when you correlate that information, what is the conclusion of that? And do you want to take rapid action based on that? So we saw earlier already like what kind of events are relevant or not. This is also plays a role here. That's why we have a configurable penalty-based system with configurable thresholds. So basically what this means is that there's all kinds of security events and you can associate a certain amount of penalty points with those events. So obviously your most relevant events will get more security or penalty points than your less relevant events. And events like something which is blocked from the outside yeah, in my opinion and what we have built so far, those events don't even get points because they're not that interesting anymore, or they might get minimal points at least. Now, what we configured was a system from 0 to 100, and it's up to the user to, or the admin to configure what the threshold should be. Should that be 90, 95, whatever, whatever threshold you want to use is possible. Now, these penalty, this system and these penalty points are tied to, yeah, basically a table and a database, and they are basically given based on IP and MAC. However, as discussed in the nuts related to crack, IP and MAC are not too reliable. An IP changes. A MAC address, sometimes there's multiple MAC addresses on a device if there's multiple network interface cards, and almost all laptops will have multiple MAC addresses. There's also MAC address obfuscation, so this doesn't always work. So hostname and username are a lot more reliable. So that is sort of where the magic happens in our system. And how we get that hostname and username, I'll talk about in a little bit. Now, what if these penalty, this threshold is exceeded? What we have created so far is a case is created in SecureX casebook, and SecureX is Cisco's sort of security platform that ties into all of our solutions plus third party. So there is a ticketing system built in called casebook, and basically what we do is we create a case or a ticket in that system. Now in the future we are also looking at doing this for creating a SecureX incident. So there's also an incident management system built into SecureX, and we want to tie into that as well. But that's a little bit more complex with the relationships, etc. But it's definitely something we want to look at, and we're working on right now. Now what we're doing is we're doing two forms of rapid threat containment. One is using ICE, so the Identity Services Engine, which is Cisco's basically network access control system. And we're using the ANC API to do that. We're also doing rapid threat containment with AMP host isolation, and we're using the AMP API to do so. Now the nice thing is that we're doing this all with APIs, and in a little bit you'll notice that it's very easy to swap out these solutions for other systems if needed. Now let's have a look at the same events that we saw earlier in Hakan's slides, but now let's, for example, give it some penalty points. And here you can see some examples of what you could configure. The top events, obviously, yes, they are relevant. So those kinds of events, you probably want to give like 25 points at least. So if your threshold is 90, these should be maybe even higher, because otherwise this might go unnoticed. So you really need to think a little bit on how you want to do that. We have some best practices built in already, and obviously we're happy to discuss the points. Below you see more of those maybe relevant events, and as you can see, they will probably have a lower threshold or lower penalty point associated with it. Now, are they not important at all? No. An unusual login time is not completely irrelevant. It can be relevant if it is associated at the same time in the same host with other more relevant events. So this is really where sort of it stacks together, and if there's really a lot of different things going on, then we're pretty sure there's a compromise, and we can at that point take basically automated actions. Now before, and that's sort of when you maybe are in a danger zone, like from 50 to 90 points, what we can do is maybe just send a notification. So that's also possible. then you might not want to take the action because the threshold is not superseded yet. Now let's have a look at the system. So I talked a lot about various things, but what does it actually look like? So the first, so in the middle actually is the R system, and Hakan is a very big cat fan, and so this is basically our GUI, and with the cat Security Operations Center analyst very closely looking at everything that's coming in. So what happens is security events come into the system, and as you can see here, we now have it configured with Umbrella, which is Cisco's DNS security solution and secure internet gateway, AMP, which is advanced malware protection, which is our endpoint security solution, and StealthWatch, which is our network behavior analytics tool that can detect anomalies. But basically anything that has a REST API can integrate with our system. So again, it's very modular and it's easy to add more modules. Now, as soon as we have those security events, we will get user info for that event. What we will then do, so depending on the security event, we will maybe have the MAC address or the IP address or both sometimes, and we will check in Identity Services Engine and the Active Directory, hey, which device at this moment is this? And what we'll then do is check out, hey, let's enrich these events, and can we add any extra info? Based on that, we will decide, do we need to create a new entry in the database, or do we need to update penalty points from an existing entry in the database? So that is something, there's some logic built in to do that. The next step is actions. So we can contain and isolate. Containment is what it's called in the ICE jargon. Isolate is what it's called in the AMP jargon. But basically this is the rapid threat containment, where a host is automatically contained from the network access. So that is step 5. Then step 6 is creating a case or incident in threat response or in SecureX, and previously called CTR, but the database where we're writing to is threat response, the private intelligence store to be exact. But again, this can be any response action. So are you using ServiceNow or some other system? Feel free to add more modules. And you can also add maybe a Teams notification, etc. So here you sort of see on the left, you see the response modules, and on the right you see input modules, and also on the top middle. And in the middle bottom you see our database. Now this system is very modular, so all the GUI, the database, and all of the modules are all loosely coupled. So you can easily, basically swap modules, or swap a GUI, or swap the database if you prefer to use something else. Now, how do you install this project? So luckily, we have this completely containerized as a Docker container. So you can pull this from Docker Hub and install it with the simple command docker compose up. So it's super easy to install. All right, so that was the solution overview. Next up, I'll pass the ball back to Hakan, and he will do a demo of the actual solution. All right.
Time then for a little demo. Let's first log on to the system. We have implemented multi-factor authentication here with Duo. Need to click on the message. And the first thing we can show you here is the configuration options. We have different modules here that can be used then to retrieve events from these modules. For example, AMP, which is Cisco's endpoint security module. We have StealthBot, which is our network detection response module. And we have Umbrella, which is DNS security. And we also configure then the relevant parameters in order to get access to information from the radio server and also from our Active Directory. Also here we need to configure the different penalty points, and we do that under RTC management. So we go to the RTC options here, and here we can configure the threshold from when we should automatically then set an endpoint into quarantine. We can also specify whether or not we want to have automatic endpoint isolation from using our endpoint security system AMP. And then for each of the modules reporting security events, and we have 3 here, we can configure penalty points for different type of security events. So here we have, for example, a DNS event from Umbrella, command and control. We have been giving arbitrarily 20 penalty points, whereas crypto mining slightly less, 8. And at the same way, we can configure penalty points for the other modules as well. So here we have like a threat detected is given 35 penalty points. Then what we can do is to gather information and penalty points about different targets. So as a different targets, we have a table here for host names, where we have a host here with 34 penalty points. We also gather penalty points for IP addresses, as we said. So we have here then different IP addresses where we're gathering penalty points. You see we have one IP address here with up to 54 penalty points. And it has events from both AMP, endpoint security, and from Umbrella. Also, we are gathering information about users. So here we see the different identified users where we have penalty points. And if we want to, we can also go into further detail here and click on one user and get information, for example, about the Active Directory groups that the user is a member of, and other information that could give you more context, such as the last time he entered the bad password, last logon time, etc. And we also gather information about MAC addresses. So here we see different MAC addresses. We can click again on the device here. We can see that it's a Windows operating system, and we can see which switch, the IP address of this switch where it's sitting, and the port of the switch where this device is located. And then we could wait for the penalty points to exceed the threshold that we configured on 100. It's 54 here, but we also have the opportunity here to do a manual rapid threat containment, where we just click on the quarantine button here, and it will be then being thrown out from the network. Well, it's not necessary to throw it out from the network completely. Remember, it's you who decide what is rapid threat containment. So here we can see the host which just been put into quarantine. And what we're doing here is to redirect all the traffic from this host to a remediation site, which could also be like a sinkhole or a honeypot.
So now that we saw this great demo from Hakan, I'll close it off. I'll close the session off for today. So what is pretty cool to explain is that our project was actually took on by Cisco Advanced Services, and they basically took our hackathon project. Well, we updated it a little bit already, because obviously during the hackathon some stuff is a little bit hacky built together. So we improved that, and then we actually handed it off to Advanced Services, and they actually implemented this for a very large public organization, which is pretty cool. Now their feedback was very good because the project was so modular. Because they did need to add some third-party sources for events, but the modular design basically allowed them to add new sources and response actions to be added easily. And And it was also possible to easily use a different database or GUI. So all in all, this was really cool. So not only did we win the hackathon, but it was also actually basically embraced by our Cisco Advanced Services. Now this is a roadmap that we have, 9 to 18 months, not committed, as they always say. So we are working on this basically in our spare time, and we're always trying to improve it. So what we've actually done already is completely built this inside of the SecureX orchestrator, so that you can sort of run this as a service inside of the SecureX platform as an orchestration or a set of orchestration workflows. That is something we've actually already completed. So if you're interested in hearing more about that, please contact us. What we're doing as well is we want to create sort of simple tiles that can be used in dashboards, for example in SecureX, but maybe also in SIEM solutions or whatever, with some high level basically statistics like top offending hosts. These are the hosts that are momentarily in the danger zone. So just some sort of statistics, high level statistics. We want to build that for dashboards. We also want to add more sources for events. So for example, all kind of other Cisco security solutions like StealthWatch Cloud, Firepower, Duo, or email security. We are also definitely looking at third parties as well. So if you have any suggestions, let us know. We also want to have a look at basically creating an external database, maybe somewhere in AWS, so that it's better scalable, and that we maybe can also add some analytics to it more easily. Now we also want to, I mentioned this before, we want to also create SecureX incidents. So this is something Cisco specific. We also want to have more granular configurable penalty points per event type, per user. So maybe, as it's mentioned here, do +5 for every penalty given because this is an IT admin, or have a lower threshold for IT admins so that you can have user groups with varying thresholds. Also, we want to consider more lateral movement if lateral movement already happened. If so, we might want to contain those hosts as well. Now we also want to add machine learning. So this is obviously a very vague word, but I'll explain a little bit more what I mean in the next slide. If you have any ideas or feedback, please let us know. Now with regards to the machine learning, we basically want to ask the analysts in the GUI whether the quarantine or the rapid threat containment was a true positive. So we want to make like an easy button that they can click, yes, I've done my research and this rapid threat containment was actually saved us a lot of trouble. Now we can obviously learn, the system can learn based on that. So that is something we want to incorporate. And if it wasn't, we will ask feedback on the security event points. So maybe that security event wasn't so relevant after all. And if yes, we can use that basically to teach our model and basically say, hey, these security events together, yeah, probably we should enforce more often when in doubt. Now, when we have enough data, we obviously want to go further than this sort of manual questionnaire. We want to basically calculate thresholds for specific host groups automatically, as I made it here. So I won't go into the details of machine learning. And we also want to calculate penalty points for security events automatically. So this is where it can really start feeding and become an organism. So this is more, this is our favorite part of the roadmap. If you have any ideas, please also share it with us. With that, here is where the project is hosted. These are our email addresses. So feel free to contact us. And with that, I would like to close it off and say thank you for your time. So thank you very much from Robin, and Chippendale.